Hello, my name is Josh Bradfield, speaking on behalf of Senior Design Team 3. As a biomedical engineering team sponsored by Barologics, we work to quantify the average head and neck movement of a person for 12 hours in order to address a high blood pressure treatment. High blood pressure or hypertension is the number one risk factor for death globally and affects nearly 1 billion people worldwide. Additionally, hypertension increases with age, where up to 74% of people over 60 years old are affected. The current treatments for hypertension can limit daily life and freedom. They include lifestyle adjustments such as more sleep and exercise and daily medications. We set out to help Barologics as they design a device to help lower blood pressure. This device will be implemented into the neck of the patient. In order to do this, we must determine the patterns of people moving in the head and neck region throughout a typical day. To quantify these movements, we must meet the following criteria. Build a harness to capture the constant motion of their head and neck with a limited weight of less than a half a pound. Recruit human volunteers over the age of 40 and record their motion over a 12-hour period. Determine the number and size of each movement. Disregard any small angle change below 3 degrees. Collecting this data will provide quantitative justification to help Barologics approach the FDA. Allow Barologics to proceed in the development of a hypertension treatment device by finding out how much movement the device must withstand throughout a typical day. Our solutions include a prototype harness with 2 sensors to detect angle change, 1 sensor in the ball cap and 1 on the chest. We asked our volunteers to wear the prototype for 12 hours on a typical day. They recorded their activities on a 1 to 5 scale of perceived exertion. We then used MATLAB to process the data and sort it into bins. After 10 samples, we determined that the most common movements are between 5 and 10 degrees. Over a 12-hour period, about 45% of a person's movement are less than 3 degrees. In conclusion, the average adult over 40 years of age will move 5,637 times in 12 hours on average. Therefore, the device must be constructed to sustain a minimum of 6,000 repeated movements. This averages out to 4,380 movements per year. Now, Barologics can propose why their device will withstand normal human movement. Given more time, we would prefer to have more test subjects for a larger pool of data. We would also improve the prototype to be water resistant and include a light onboard battery to the head sensor in order to use Bluetooth and eliminate the wires. For future research, it would be great to see a published study on head and neck movement as well as other joint movements. As Biomedical Engineering Team 3, we would like to thank Barologics for the sponsorship, our participants for volunteering, and our advisors, Dr. Han, Dr. Yu, and Mark Griswa for advice along the way.